Welcome to this session, Oracle AI Database 26AI, Revolutionizing Data and AI Integration. Now, after a brief exploration of data use scenarios, I'll explore two key technologies, Select AI and Autonomous AI Database MCP Server, helping to enable this data and AI revolution. I'm Mark Hornick with AI and Machine Learning Product Management for Oracle AI Database and Autonomous AI Database. Let's first touch on typical data use and AI integration approaches. Business users want answers to their questions quickly using their enterprise data. Applications, which is what they typically use, provide no-code interfaces to answer common anticipated questions, but it's difficult to go beyond the provided functionality. Analytical tools enable more custom answers, but this requires tool expertise and an understanding of the underlying data schema. For truly challenging questions, developers may write code and bring in other data sources. Then enters the AI chatbot, supporting a wide range of users from business users to developers. By themselves, LLMs don't have access to your private data, so they're prone to hallucination. And unless you're hosting your own model, you're sending prompts and data to a third party, a possible security concern. You need to prompt carefully and then scrutinize results as well. Now, custom applications augmented with AI can help with anything from writing emails to summarizing large volume content and suggesting options. The application, with access to your structured data, can use the LLM to provide more relevant and grounded answers to your business questions. But consider unstructured data. Think product documentation, service requests, and even log files. A technique called retrieval augmented generation, or RAG, can help reduce hallucinations by grounding LLM responses with your private data. Leveraging RAG can require a custom implementation to vectorize documents in a vector index using a separate vector database, find relevant chunks matching your prompt, construct an augmented prompt, and invoke the LLM to synthesize a final response. Moreover, this solution needs to be updated as new content arrives. Another powerful technology involves AI agents. They're like smart helpers, software programs designed to independently carry out specific tasks or solve problems for you. They can read information, make decisions, and take actions on their own or with human approval, based on the instructions and goals that you give them. Examples of AI agents might include customer support agents to handle troubleshooting, ticket routing, and help desk escalation, and financial research to gather and analyze market data or produce investment briefs. Agents use LLMs to determine which actions to take given a user's request and which tools to select to achieve a given task. These are often custom implementations using a wide range of possible infrastructure or adapted from pre-built agents, although some AI providers are offering tools to streamline agent creation. Then comes MCP, a specification designed for connecting AI models to external tools, data, and systems in a standardized way. An MCP client is a special type of agent that may use an LLM to determine which tools to invoke, when, and how. For querying a database, a user may ask, "What are my total sales by region over the past quarter?" The MCP client uses tools to determine which schemas and tables are available, get table metadata, generate a query using the LLM, and invoke that SQL, all using tools from the MCP server. Now, typical MCP servers are custom implementations. They often specify a fixed set of tools the MCP client can work with. And tools may include database functionality, internet access, and interaction with other systems. So, we've seen multiple ways you can interact with your data and leverage AI to enhance results. However, what you've also seen is that this can involve multiple component technologies, and in many cases require developers to integrate them and code solutions. Ultimately, deriving value is challenged by this complexity and overhead. Now, you can derive greater value from your private data and generative AI with reduced overhead and complexity using Oracle AI Database and Autonomous AI Database. Whether you're a business user, technical user, developer, or DBA, the converged Oracle database helps to simplify solutions, enhance security, and streamline interaction. Start with Select AI for querying data using natural language and RAG, among other features, using your choice of AI providers and models. The Select AI agent framework enables you to build AI agents directly in and run from your database. Use built in tools or craft your own. Use the built in vector store support in combination with Select AI. Benefit from MCP with the built in autonomous AI database MCP server that you can use from your favorite MCP client. Or use the Ask Oracle chatbot powered by Select AI. Implemented using Apex, it enables no code interaction for NL to SQL, RAG, and AI agents using natural language. These AI use cases are enabled and simplified by your Oracle database, whether on premises or in the cloud. And so let's dive into Select AI. Select AI started by enabling users to query database data with natural language on autonomous AI database. However, over the past few years, it has expanded well beyond this, advancing its natural language to SQL capabilities and introducing features like retrieval augmented generation, text summarization, translation, and AI agents. Further, it's also available for on-premises database users with release 23.26.1 and 19.30. Today, we can move seamlessly from asking questions to getting deeper answers to taking actions using powerful agentic workflows. Now, Select AI strives to reduce the distance between business users and their data. It helps developers produce AI enhanced applications by giving convenient and easy access to AI models using SQL, PL SQL, and Python. You can think of Select AI as Oracle's in database gateway to AI models, fully integrated, secure, and built for enterprise scale. As I'll discuss next, Select AI automates many key generative AI use cases, making it easier for users to get better answers from their data using generative AI. Let's highlight some of the key capabilities. Select AI supports natural language to SQL to easily generate, run, and explain SQL queries from simple text, making data extraction and insights more accessible to more users. Engage with large language models for chatbot like experiences. Simply enter your prompt, whether it's to generate custom emails or code or run sentiment analysis. Retrieval augmented generation, or RAG, allows you to ask questions and receive more accurate, relevant responses powered by content from your trusted private documents. Select AI also supports generating synthetic data. Here, you use LLMs to create data that matches your database structure. This is especially useful for testing, debugging, or kickstarting new projects when real data isn't available. Select AI enables creating and running in database AI agents. Build and run interactive autonomous agents directly within your database to automate tasks and streamline processes. Select AI also supports text summarization and translation. It can reduce the complexity and language barriers with built in options for summarizing and translating text. This is a quick summary of key features available by database type. The main differences between 19C and 26AI are RAG-enabled features, which rely on AI vector search, a 26AI feature. Now, to get the full Select AI benefits, 26AI should be your target. But does all of my data need to be in Oracle? Well, many customers store data in a variety of sources and are often unwilling or unable to migrate their data. But that's not a problem for Select AI. Using what we've called an AI proxy database approach, or what we've also referred to as a sidecar, you can extend Select AI beyond your database by mapping external data sources as objects in your database schema, making your Exadata database as well as autonomous AI database your front end to remote data. If Select AI can see such tables or views, it can leverage your LLM to generate SQL across them, what are called federated queries. And this spans Oracle and non-Oracle data sources, whether in the cloud or on premises. Now, to highlight the type of generative AI interaction that Select AI enables, we provide the Ask Oracle chatbot. This is a sample Apex app that you can download and install in your database. It allows you to easily interact with your database for chat, NL to SQL, RAG, and AI agents using objects that you create with Select AI. Users can see the specific queries generated and have queries explained, chart results, edit their conversations, and switch between conversations, all with no coding. Here's a brief demo for NL to SQL. First, we begin by logging into the Ask Oracle Apex application. To begin, we'll set the conversational style to NL's a SQL by clicking the plus button in the prompt bar. Now, once enabled, you can interact with your database using natural language. Select AI using the LLM you specify automatically converts your prompt into SQL and runs it against your database tables in a conversational interface. Now, with the database checkbox selected, let's ask the application to retrieve the details of the top 10 customers with the highest total purchases. After submitting the prompt, the results are displayed automatically in a table. If you want to review how the query was generated, click the Explain button, and this provides a detailed explanation of the generated SQL statement, including how the results were computed. Now, next, let's generate a visualization. Enter a prompt such as plot a pie chart for the above results using customer ID and total spending. Now let's enable the Narrate checkbox and submit a new prompt. The Narrate option uses the LLM to generate plain text from the SQL query results, making it easy to understand the insights without reviewing tables or SQL. And finally, using the same AI profile, you can chat directly with your chosen LLM. To do this, simply uncheck the database checkbox and enter your prompt. In this way, responses are generated by the LLM, not using your database metadata. So, which AI providers and AI models can you use? Well, Select AI doesn't lock you into a limited set of AI providers or models. You have the flexibility to choose from a broad range, and you can easily switch between them as needs evolve. Select AI supports any OpenAI compatible provider, making the range of options open ended. Additionally, Select AI enables the use of customer managed, privately hosted OpenAI compatible LLMs for greater control and security. Now, it's worth noting that not all LLMs are equally capable. For example, some might do well for SQL query generation, others for marketing content or creative works. Some LLMs are good at spoken language translation and understanding multiple languages. But what if my LLM is great at translation, but another is better at SQL query generation? In such a case, you may want to translate using one LLM into the language that a second LLM that excels at NL to SQL generation can handle. And we allow you to do this easily within Select AI. How do we use Select AI? Well, as you can see on the right using a SQL worksheet, you can specify a standard select statement with the keyword AI and your prompt. You can view the generated SQL or have Select AI run the query and provide the result, as we see here. You can also view the augmented prompt with its metadata and instructions. Get an explanation of the generated query, or have the LLM generate a textual response based on the data returned. It's worth noting that Narrate also automates the retrieval augmented generation process. The chat action allows you to get responses directly from the LLM, say for creative content generation. While you can use Select AI from a SQL select statement, there are also PL SQL functions and procedures, as well as a Python API for you to use. Let's look at NL to SQL more closely. Now, this is the SQL query generation pipeline for Show SQL. The process begins when a user submits a prompt or a question such as, what are our top 10 streamed movies, or find the top 3 baby boomer big spenders. The second example really demonstrates how the LLM uses its general knowledge to understand concepts like baby boomer or big spender. And to generate queries tailored to your specific database, Select AI automatically enriches the user's prompt with metadata from your database schema. And this includes table definitions and optionally table and column comments, constraints, and 26 AI annotations. The pipeline then creates an augmented prompt, which is sent to the LLM to generate a SQL query that can run against your database data. At the heart of Select AI is the AI profile, and this is where you configure how Select AI should interact with AI models. Here, we're showing an AI profile for NL to SQL generation. You choose your provider, LLM, and the list of tables or views you want the LLM to consider when generating SQL queries. And this is just one example of an AI profile. Users can specify various settings to affect Select AI and AI model behavior, as well as work with vector indexes for RAG. A new feature, feedback, enables you to correct syntax, adjust filters and joins, clarify ambiguous natural language prompts, and supply corrected SQL queries. This provides a dynamic feedback loop to improve query accuracy based on knowledgeable user input. Here's a brief demo. We're asking, what are our top projects? And we see that we get one response. And if we ask to see the sequel for this, it's rather basic. So we want to give feedback to say, let's base the top projects on actual cost, include cost and budget in queries. So now, when we run what are our top projects, the feedback is provided in the augmented prompt to the LLM. And we receive the result that we wanted. Now, another advantage of Select AI is the ability to embed AI capabilities directly within your SQL queries, enabling scalable pipelines for AI driven content generation, filtering, and aggregation. This approach allows you to leverage the core Oracle SQL engine for efficient, cost effective processing while seamlessly integrating generative AI. With Select AI, you have a unified, integrated platform for building robust AI pipelines within your applications, integrating data and AI processing. For example, you can use the chat action to combine instructions with content from the product feedback column in our customer feedback table. Similarly, you can easily summarize feedback for each product using a summarize action by creating a JSON object of feedback grouped by product. I wrote a blog on this referring to supercharging SQL, and it has more examples. Let's move on to RAG. RAG combines two key strengths: retrieval-based AI, which uses vector-based semantic similarity search to find relevant information, and generative AI, where LLMs create context-aware responses. The central idea is to provide the LLM with new trusted knowledge without the need for costly fine-tuning. RAG has clear advantages, from increasing accuracy to security. But let's take a high-level look at the RAG process. First, retrieve information relevant to the user's prompt from a vector database. Then, augment your prompt with these relevant document chunks. And finally, send this augmented prompt to the LLM, and this generates a response that incorporates the up-to-date retrieved content. At a more granular level, the typical RAG pipeline starts with data sources that are loaded into a repository, such as cloud storage. From there, the documents are broken into smaller chunks, perhaps using a sliding window technique. Now, each text chunk is transformed into a vector. A vector is a high-dimensional numeric representation that captures the semantic meaning of the text. Each vector is then stored in a vector database, and a vector index is created to accelerate searches. Next, when we want to perform a search, the user prompt is converted into a vector using the same transformer model. The system quickly compares this query vector to those in the vector database. Now, with millions or even billions of vectors, a naive search would be computationally expensive, so advanced indexing techniques are applied to enable fast, accurate retrieval. With RAG, we use this process to identify the top matching document chunks based on semantic similarity to the user's prompt. And these selected chunks, along with the prompt, are then combined and sent to the LLM, which generates a response that incorporates the retrieved up-to-date information. Of course, when new information becomes available, the vector database should be updated to ensure the latest knowledge is included in future responses. Select AI automates RAG and reduces it to two simple steps. You create an AI profile, then create a vector index, which can be automatically updated if new content is added to your documents. At that point, you can start asking questions, so that complex process that we just saw is greatly simplified. Select AI simplifies the RAG workflow so any database developer or user can take advantage of it. It's seamlessly integrated with AI vector search and handles the full RAG pipeline. You could literally start using RAG on your documents in a matter of minutes. Now, earlier we looked at the AI profile configured for NL to SQL, and this shows an AI profile configured for RAG. The main difference is the inclusion of a vector index and optionally an embedding model. Next, we create the named vector index using our AI profile, which specifies the provider and model. Now, during vector index creation, we also specify the location of the documents to be processed. While SQL and PL/SQL are core to Oracle database, Python is a preferred language for many users. In this past year, we released a Python API so developers can take advantage of the rich Python ecosystem and get results directly in Python data structures. In the code shown here, we specify an AI profile and invoke functionality like run SQL and narrate with prompts. We recently released version 1.2, which also supports Select AI Agent, along with other new features. Now, Select AI Agent is an autonomous agent framework provided through the DBMS Cloud AI Agent package. This framework allows you to build, deploy, and manage AI agents with support for what's called the React agentic pattern for reasoning and action, which is shown here on the right. A key benefit is that the database orchestrates the agentic process, enforcing Oracle's robust security controls. The agent interacts with the LLM by sending only an augmented prompt and receiving the necessary tools or responses to drive its actions. Select AI Agent supports custom and built-in tools and short-term and long-term memory for multi-chat conversations. Additionally, it enables import and export using the Oracle Open Agent specification, enabling interoperability with other tools that support this format. So consider a scenario where your question can't be answered using only data in your database, like what percentage of your country's residents are customers. And this requires knowledge of the population of your country. So questions like this benefit from combining database knowledge with web search results. Let's look at an agentic use of Select AI NL to SQL. Now, agentic Select AI for NL to SQL is an agent built using core Select AI capabilities, and this agent is configured to use the sales history schema. The agent also leverages web search to supplement NL to SQL results. Now, we'll ask a simple question. Of the total UK population, how many are my customers, and what are the total sales in the UK? And once the prompt is submitted, the agent automatically begins analyzing it step by step. First, it constructs and runs the required SQL queries to fetch customer counts and total sales figures. Then it goes a step further by searching the web to retrieve the latest population data for the UK. Once all the information is collected and processed, the agent compiles the result. And here you can see also the sources. And you can review the agent logs that contain the detailed steps taken by the agent for greater transparency. Next, let's get a quick view of the Autonomous AI Database MCP server, which is available with ADB Serverless and Dedicated Region. Consider adopting Dedicated Region if you want to get this on premises. Now, we touched on MCP earlier, so just a quick recap. MCP can simplify how applications provide LLMs with data and functionality, such as obtaining knowledge from the web and taking actions in external systems, without having to hard code point-to-point integrations. With MCP, you can discover tools provided by the MCP server, understand tool parameters and their intended use, and invoke them, all while maintaining conversational context. So instead of custom adapters, MCP offers an open universal interface. Now, the ADB MCP server is a multi-tenant built-in feature of ADB Serverless and Dedicated Region that exposes MCP endpoints. It's supported on both 26AI and 19C databases. By being built into ADB, this MCP server requires no customer-hosted infrastructure. And after a few simple steps, you can use your database with MCP-compatible clients like Claude Desktop, VS Code with Klein, and OCI AI agents to invoke tools that you define with Select AI Agent. Now, since ADB natively integrates with Oracle Database Identity for authentication and authorization, you can discover schemas, run SQL, and use database features, all governed by your database's security policies. Also, ADB MCP Server is available with ADB Multi-Cloud for Azure, GCP, and AWS. In a typical database MCP architecture, each remote system may require its own standalone server and infrastructure, independent of the database itself. And this approach requires additional resources to deploy, manage, and maintain the various MCP servers. The set of available tools is typically fixed and determined by the MCP server implementation. With the ADB MCP server, the server is natively integrated into the database platform as an Oracle hosted mid tier service, eliminating the need for separate infrastructure. The ADB MCP server requires no additional eCPUs, and there's no separate MCP compute charge. Billing is part of the normal ADB usage. The result is a streamlined, more efficient architecture with fewer components to manage. In addition, your database, acting as an AI proxy database, can access other remote databases, both Oracle and non-Oracle. This AI proxy database concept, as you noted, is also referred to as a sidecar, enables the database to handle federated queries efficiently and securely. Select AI functionality can also be exposed as tools, supporting capabilities like NL to SQL and RAG for use by your MCP client. Here's a demonstration using Claude Desktop, which uses OAuth authentication.
In this demonstration, we'll show how to use Claude Desktop with the Oracle Autonomous AI Database MCP server. First, let's configure Claude Desktop. Our user, Chand, opens the developer settings to edit the MCP configuration file. Chand enters the MCP server JSON configuration, specifying the ADB MCP endpoint among the required parameters, then saves the changes. Now, we're ready to sign in using OAuth authentication for secure access. Returning to settings, we can see the MCP server is now running. Let's explore the available tools for the MCP server. To streamline our workflow, we'll set these tools to always allow, so interactions continue without manual intervention. Now, we're ready to start a new chat session. We'll request a pie chart that shows the distribution of total sales by channel. The MCP client automatically lists available schemas and objects, retrieves the necessary details, and generates and executes the SQL query. At this stage, the language model generates the HTML code for the pie chart visualization. Finally, Claude Desktop displays the database results, complete with the interactive pie chart.
So, what are actions you can take today to prepare for your AI journey? Well, if you're interested in asking natural language questions of your database data, start by assessing your database tables and views for intelligible metadata and augment them where needed. This can include adding table and column comments or 26 AI annotations that describe the table or column, especially for those that are cryptically named. Table metadata can play a significant role in SQL query generation. It's more about how you describe your data than even the data itself. Next, select one or more AI providers and try the Select AI NL to SQL workshop through the Oracle Live Labs, which is linked here. If you'd like LLM answers grounded in your private documents, use Select AI RAG. Identify use cases that could benefit from receiving customer responses using your private text documents. As we showed earlier, you can easily create an AI profile and vector index and then start asking questions. Give this a try using the RAG Live Lab, shown here. And maybe you want to automate certain workflows. AI agents may be the answer. Brainstorm candidate workflows for automation, perhaps those that are repeatable and text-heavy, or involve decision and routing activities. Identify measurable business goals like reduce cycle time, lower costs, and increase conversion. Break work into agent-friendly tasks like extracting fields, classifying intent, updating records, sending messages, or even scheduling events. And yes, there's a live lab for that too. Here are a few resources you may find useful. Our blogs announce and explore features, with several that are linked here. In addition to documentation, there are links to download the Ask Oracle chatbot, live labs, and other videos. We'll be publishing a new live lab for the ADB MCP server relatively soon. So, thanks for learning about Oracle AI Database and Autonomous AI Database and how they enable you to take advantage of the data and AI revolution.